Hello. Well, in this video, we will be calculating the inverse of this matrix A. Okay, so what I will do is I will write the matrix as is and attach the identity matrix to the right of it. And then apply row operations. Those are elementary row operations. Exchanging two rows, interchanging two rows, add a constant multiple of a row on another row, or multiply a row by a non-zero constant. If we can do that and be able to write it after row operations, the identity matrix on one side and whatever we get on the other side, then this is going to be the inverse of the matrix A. So let's do that. Okay, so what we're going to do first is subtract 5 times the first row from the third row. So row 3 minus 5, row 1, I'm going to put it in row 1, in row 3 I mean, so I get a 0 here. This is already 0, so I'm not going to mess around with the second row, but I'm going to work with the third row. So I have 1, 1, 1, 1, 0, 0, 0, 2, 3, 0, 1, 0. So I'm going to multiply this by 5, so that will give me 5, 5, 5, 5, 0, 0, subtract. So 5 minus 5 is 0, 5 minus 5 is 0, 1 minus 5 is minus 4, 0 minus 5 is minus 5, and then I have a 0 and a 1. Okay, so that's first step. Second step, I'm going to change this to a 1 by dividing it by 2. So 1/2 of row 2 will sit in row 2. Okay, so 1, 1, 1, 1, 0, 0, 0, 1, 2, 3 halves, 0, 1/2, 0, 0, 0, minus 4, minus 5, 0, 1. Left everything alone. Next, I will subtract the second row from the first row so I can get a 0 at this position. Okay, so row 1 minus row 2 sits in row 2. So I have 1, 1 minus 1, 1 minus 3 halves is minus 1/2, 1 minus 0, 0 minus a half is minus a half, 0 minus 0, 0, 1, 3 over 2, 0, 1 over 2, 0, 0, 0, minus 4, minus 5, 0, 1. Next, I'm going to make this as a 1 by dividing the whole thing by minus 4. So minus 1/4 of row 3 sits in row 3. Okay, that gives me 1, 0, minus 1/2, 1, minus 1/2, 0, 0, 1, 3 halves, 0, 1/2, 0, 0, 0, 1, 5 over 4, 0, minus 1 over 4. Okay, what I'm going to do next is try to make this two zeros. Okay, for that I will add 1/2 of this one, this row, on that one. Okay, so 1/2 of row 3 added to row 1 sits in row 1. Okay, so I get 0, no, alright, 1, 0, 0 is 1/2 of 1 added to that. Half of 5/4 is 5/8, plus 1, which is 8/8, is 13/8. Half of 0 is 0 added to that is minus a half. Sorry, minus 1/2. 0 plus half of 1/4, or subtract half of one, add half of 1/4. That's 1/8. So minus 1/8. Okay. 0, 1, 3/2, 0, 1/2, 0, 0, 0, 1, 5/4, 0, minus 1/4. Notice that I could have done 2 steps at once, but I made sure that I'm doing 1 step at a time, because if I make a mistake when I check at the end, I can spot where the error is and then follow through and doing the same thing, follow through and then fix my errors. Alright, next what I will do is I will subtract 3/2 of the third row from the second row, so I can get a 0 here. Okay, so minus 3/2 of row 3 added to row 2 sits in row 2. So I get 1, 0, 0, 13/8 minus 1/2 minus 1/8 for the first row, no change. And 0 minus 0, 1 minus 0, 3/2 minus 3/2 is 0. 0 minus, what's 3/2 of 5/4? Well, 3/2 of 5/4 is 15/8. So that gives me negative 15/8. And then we have a 1/2. And 0, 3/2 of 1/4 is 3/8. So when you subtract that, you get plus 3/8. And 0, 0, 1, 5/4, 0, minus 1/4. So we can see that I have the identity and a matrix B, which is going to be presumably A inverse. Okay, so A inverse I'm claiming is the matrix 13/8 minus 1/2 minus 1/8 0, 1/2. No, which one am I reading? So minus 15/8, 1/2, 3/8, and 5/4, 0, minus 1/4. Okay, so you notice that I did one row. I took care of one row at a time. If you do, I could have done multiple steps at once, but usually what happens is if we do that, we make mistakes. Or so now we can check that A times A inverse, this guy, is the identity. We can check that. So if this didn't work out, we can go back and fix our error. And the other thing is, if we get a 0 matrix here, or I mean a 0 row, 0, 0, 0, then we know that the original matrix is not invertible. Okay, so let me do one quick example, which I've already worked out. I'll just write down what A is and what, once you do a couple of steps, what you get. Okay, so if you do A equals the matrix 1, 2, 3, 1 minus 2, 1, and 5 minus 2 minus 3, you attach that to the identity matrix, your argument, the identity matrix on the right, and do a few row operations. I did 2 operations. I got 1, 2, negative 3. 1, no. Oh, this was negative 3. Okay. That would make a difference, of course. 1, 0, 0, 0, 1 minus 1, 1/4 minus 1/4, 0, 0, 0, 0, 2 over 12, that's 1/6, minus plus 1/4, and 0. That's what I got after a couple of steps. So you notice that this would never be the identity matrix. You notice that I will never be able to get this row equivalent to the identity matrix. So that's not going to be possible. And therefore, the original matrix A is not invertible. Okay? Alright, so I'll go back and show you quickly a nice, beautiful example that's done in your textbook. So you can see that they have a matrix A. They tacked on the identity matrix on the right, and they did row reduction, and they got the identity here, and this is the inverse of A. Okay, that's a beautiful example in your textbook. Another thing that I want to say is, in this example, in the previous example I did, I purposely chose a matrix that has fractions in it. So when we have fractions, all we have to do is just be a little more careful, just careful, and then we'll be able to do the inverse properly. Really not that difficult, that different. So finally, I'd like to give you an exercise. The exercise is find the inverse of A, which is minus 3, 8, 1, 2, minus 6, 2, 2, minus 6, 3. And what I want you to do is use this method that we did here. A inverse using row reduction. All right. Thank you. I'll see you in class.